We're going to do related rates. Why are they called related rates?
Because they change.
What's they?
Like, because as change, because as a part of something changes, for example, 3
Isn't it like
Oh, we don't quite know, do we?
dy is dx? The change of area?
Well, you're talking to me about how to do it, but what is why are they called related rates?
Because
rates of different things are related.
Okay? Justin says the rates of different things are related to their derivatives. You know, or the functions are related to those rates. No, he does not memorize it. Okay, so we're going to do this. If you, Sam, Justin, if you go to the very last page, it gives you the steps for those of you who like to have steps. So if I go here on my smartboard, there are the steps. Read the problem. It's really important to read the problem.
It's the same as one from last year.
Yes, it is. Draw a diagram. So we know how to do this, but I'm just trying to remind you, and then we're going to work on free response questions, and then you can work on trying the assignment. Now, the first ones aren't too bad, but
These problems from last year, these seem like the exact same thing, or these were like twist to it.
no, they're exactly the same.
Oh.
So why are they harder?
Why are they what?
They're harder.
The ones in the book are harder, but I'm just trying to get you to remember this one. Here we have a small balloon being released. You will. Okay? At a point 150 feet away. Matt, do I have to put you someplace else? I will. That's it. That was your warning. Okay. 150 feet away from an observer who is on level ground. If the balloon goes straight up at a rate of 8 feet per second, how fast is the distance from the balloon to the observer increasing when the balloon is 50 feet high? We do the find, given, when as an aid to help you, it's not in order, to help you figure out what you're doing there. Okay. Yeah, these are all out of order now. What kind of physics? And by the way, did everybody get the purple one? The homework kit really helps you with the questions. Yes. Okay. So sometimes on the AP exam, they give you a point for the find, given, when. No. Okay. It's one at a time. The balloons are released at 150 feet away. Now what I want to do is label this diagram with things that are constant. This is 150 feet here. That isn't going to change. That's a constant. But this is changing, and this is changing. What I have here with this triangle is simply a snapshot of what's happened. It's at some particular time, it'll look like that triangle. But it's always changing. You know, here you could have this triangle, you could have this triangle, you could have that triangle. You have all those different possibilities. So then you're going to take a picture. But you can't put the values in until you actually set up the equation and done derivatives. So let's see. It's released at a point 150 feet away. It says if the balloon goes straight up at a rate of 8 feet per second. So look at the blue one. It's rising at 8 feet per second. That's given. So I'm going to write this into my given. How fast is the distance from the balloon? So the balloon's going to be here at this instant. And there's the observer. I want this distance, how fast it's changing. You can. I can find the distance, but I don't want that. I want the change, how fast the height is changing. Maybe. You can try it. But I'm just doing this as an example. What would you like to call this distance here? Because it's changing. What letter? Y. Okay. Then what do you want to call the hypotenuse? Oh, I don't like X. How about R? Doesn't matter. Okay, what do I want to find? How fast is the distance changing? So the change in what? R with respect to time. And what is the 8 feet per second? It's the change in which one? No, not X. Y. That's why I didn't want to use X. And when the balloon is 50 feet high, so what's 50 feet? H. And I just do this to help me organize my thoughts and see what the relationships are here. And in my mind, the key to doing all this is to look at your rate for the find and the given, and that's the one you want to relate. You want to relate R and Y using the information that's in the diagram. If I were given an angle, I would not use Pythagorean theorem, because that doesn't make sense. So how do you relate R and Y? Using some geometry. Whose theorem? With the right triangle, y squared plus 150 squared is equal to r squared, right? And make sure you put in the things that are constant. That is constant. The height of the balloon at 50 feet is not constant. That is changing. And now what do? Don't solve for r or h. That's hard. Let's take the derivative with respect to what? Time. And you know you're going to see these. By the way, you do have copies of all the exams and all the multiple choice. But we'll be giving you paper copies. But they are online. So what is the derivative of y squared with respect to time? Okay, that's 2y is with respect to y. Then you have to do the derivative of the inside function with respect to time, implicit differentiation. What's the derivative of 150 squared? 0, good. And the derivative of r squared is 2r dr dt. Well, I don't like those 2's. I can divide both sides by 2 and get rid of the 2's.
But is our y the r?
Well, yes, if you use the h, that's what it would be. Okay, I got to fill in what I know. Do I know y? Oh, I do. Oh, yeah, I called it h. I'm sorry. I should have called it y. So y is 50 feet, so that's 50. I don't know how fast this is going up. Do I know r? Oh, wait, I do know y. That's 8 feet per second, yeah. Almost. This is 8. And then it's r, which I don't know, but guess what I can find, times dr dt. Yeah, but let me show you the easy way to do this. Well, I think it's easy. Now, at this instant, we're going to take a picture exactly when the balloon's 50 feet high. This is always 150. Now, I'm lazy, and I don't have a calculator on me, so I don't want to work with that. I want to work with numbers I can work with. So I'm going to divide by 50, and 50, I'm going to reduce my triangle to a smaller version because they're similar. The ratios of the triangles are still the same. Okay, so what's the hypotenuse going to be with my little triangle? Square root of 10. Now, you can't simplify that, and I wouldn't anyway. Now, how do I get back to the big triangle? Multiply by 50. So that this is 50 times the square root of 10. If you were given the, you could leave it the square root of whatever it is, because they don't care about the arithmetic. But if it's multiple choice, it doesn't matter. And then what do? We divide by 50, square root of 10, and by 50, square root of 10, and no need to rationalize. No need to put it into a decimal. If you put it into a decimal, and I wasn't picky on the exam, I should have been, but I wasn't. If you gave 2 decimals, you should have lost a point. I decided to look the other way on that, but on the AP exam, they will not look the other way. 3. You can, but you must have 3 decimal places. You can have more, but you have to have at least 3. So we never look beyond the 3rd one. But if you don't have 3, then we're going to take the point back. Not nice. Now we can do one more, because this is a similar triangle one. And then we can work on our free response. Just because I'm thinking in the homework, there's one that has similar triangles in it.
We worked with first?
Sure. Let me read it. Water's pouring into a cistern. You guys know what a cistern is?
It's like a container.
Yeah, it's a well. It's a container. On my farm, I used to have a cistern.
But no flat.
Probably not. Probably a cylinder. Mine was a rectangular prism, I believe. Okay. It's going in at the rate of 8 cubic feet per minute. I love to look at the units because they tell me so much. What are cubic feet per minute? Volume. That's the change in the volume as time changes. So if you can't figure out what it is, look at the units because they'll give you units on these. And the height of the cistern is 12 feet. The radius of the circular opening is 6 feet. How fast is the water level rising?
So volume, we don't even need to use this. Isn't it?
Yes, we do. Well, that's...
R squared.
Okay, they will give you the formula for volume, but before I do that, let's find the given and when. Well, how do you know you need this formula? Until you do the find and the given and the when, because that tells you what you're relating. And we also need to make sure we're all on the same page with our variables. So this is 12 feet, right? This is 6 feet. Now the water is changing. It's moving. It's like this. So what do you want to call that height? H. And what do you want to call this radius? R. Is it different at different heights, the radius? Is it changing? What about the radius up here? That's different, isn't it? Okay. So do your find and your given and your when. We already know that we have 8 feet per cubic feet per minute. And you already told me that was dV/dt. What do we want to find? How fast is the water level rising? You might have to read twice before you figure out which one that is. Yeah, it's dH/dt. And it's when the water's 4 feet deep. So what's 4 feet? H. And honestly, even when you get into the AP exam, and there always be a little twist probably, but this tells you what you want to relate. And they will give you the formula. I want to relate the volume and the height. And if you look at the rules and the steps, I shouldn't really call them rules, they're not that. It says, rid yourself of unwanted variables, because R and H are both changing, which means you have to use the product rule if you try to differentiate now. And before you differentiate, simplify your equation. So let's write it down. Volume equals 1/3 pi r squared h. And both r and h are changing. You can take the derivative as written, but you're going to have to use the product rule. Plus, I'd have to know what dr dt is, and I don't. So we got to go back here. We got to get rid of r squared or h. Why? Okay, because I want to find dh dt, although sometimes it's easier to work in r. Now I'm going to slide that out. There we go. This is 12. This is 6. What's special about these little triangles? They're not the same. They're proportional. They're similar. So now a lot of people want to put the h is equal to 4 here, right, and now, but you can't do that because it's changing. Anything that changes, you cannot make a constant. You have to first do all the derivatives, and then you put the 4 in at the very end. So what is this ratio? R is to what? 6 as H is to 12. I did little to big, little to big. And so R equals 1/2 of H. And I will do that, and I will simplify before I try to do a derivative. And it's really simple when you do that. So I'll let you try it. So that dV/dt was, what was the dV/dt? 8? equals, then this will reduce pi over 4 times h squared. What's h? 4 squared dh dt. And arithmetic should be easy for you, but it's 1/4 of 16. If you cancel out one of the 4s, it's 4 pi dh dt. So that's 2 over pi.
Can you show where you get the pi over 12?
Yes. I'm going to substitute in r equals 1/2 h. So it's 1/3 pi, and it's h over 2, but you have to square it. So you have to square the denominator. This is h squared over 4. These are way easier than what... Now, the first 3 are not too bad, but then they get hard. Start on your your problems. No, because it says day 1 and 2. We are really going to spend 3 days on it. We're going to spend 3. Yeah, you do. Get started on these problems. 1, 4, 15, and 16 aren't too bad. Then they get tougher. And then we're going to have you present them. And then I'm going to collect it from everybody. No. We have 3 days in this section. You should have something started for tomorrow. I do have a couple books. Yeah, there's one up there. I think there's one on my cart. Okay.